Okay, so in the last lesson, we finished with the problem. Find the a to the seventh, b to the sixth term in a plus b to the 13th. And you said, okay, I know this is a term. This is definitely a term because the sum of the coefficients is 13. The question is, what was the binomial coefficient? And we knew it was like the 13 choose 6. This is the coefficient. We can put it in our GDC. Please know how to do that. Let's explore this a little bit more. Let's explore exactly what this is. So n choose r, it's n factorial over r factorial times n minus r factorial. And we recall that n factorial was like n times n minus 1 times n minus 2 all the way down to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Once again, if the number starts to get really large, you know it's a calculator problem. So, for example, 5 choose 2. For example, it's not part of the SL course, but this might answer the question. There's 5 kids in the class. I need 2 kids to help me move books. How many ways can I choose 2 kid? 5 choose 2. So it's 5 factorial over 2 factorial times 5 minus 2 factorial. If you don't have a GDC, write the numbers out. 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Out, 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 out. This equals 10. And we saw, actually, that this was one of the entries in, what it was a 1, 5, 10, 10, 5, 1. When we raise something to the 6th power or to the 5th power. Yes, when we raised something to the 5th power, we had 6 entries, and it was 1, 5, 10, 10, 5. I can quickly write that 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 5 choose 2, 5 choose 1, 0, 5 choose 1, 5 choose 2. Okay, let's do another example. How about a 6 choose 4? 6 choose 4, 6 factorial over 4 factorial times 6 minus 4 factorial. 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 2 times 1. Once again, put it in the calculator or do this quickly. This goes out with this. That goes out with this. And we have 15. This is 6. I can do another entry. 1, 6, 15, 20, 15, 6, 1. Let's see. 6 choose 4, 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4. Works out nicely. Couple of observations. N choose 0. How many ways can I not do anything? 1. And N choose 0 and choose 1. If I have n objects, how many ways can I choose one of them? Well, n. And so a couple of cool things. We see that this n choose 0 is actually n factorial over 0 factorial times n minus 0 factorial. But I can just switch this around. Right? And then this turns out to be n choose n. And that's why all the rows are all 1s. These are all 1s. So that's why along the corners they're all 1s. Am I going to test you on this? No. Will you have a calculator? Yeah. What else? So how about, and then what's going on with this one? This is kind of cool also. If n choose 1 is n factorial over 1 factorial times n minus 1 factorial, well, I can switch this around. N factorial times n minus 1 factorial times 1 factorial. Well, this turns out to be n choose n minus 1. That's also why the second inside is the same thing. And so you could say, so the question that you might say is, if you have 52 objects and you have to choose 51 at a time, how do you do that? Well, let's say you didn't have a calculator. Or you could say, oh, you know what? This actually is the same as n minus 1, and this is the same thing as 52 minus 51, which is 52, choose 1, or just 52. Once again, you'll have a calculator for this. Let's see, let's move on. I'm going to do some more stuff in. So the question is, yeah, good. So what are questions you're probably going to get on IB? Let's move the screen. I apologize. Let's see. So let's erase this. Let's see. What are you going to get from IB? They're going to say, well, what is the x to the squared term of 2x plus 1 to the 6th power? And so you would, to the 4th power. Let's make it to the 4th power. So you would say, okay, well, I know that every single term, has its 2 to the x, and then it's 1. So, so you have the coefficient, and then each term raised to a power. Well, I'm looking for the x to the 2 terms, so 2x squared is going to be raised to the 2nd. What goes here? Well, you know what? Let's make it to the 3rd. Let's make it to the 5th for fun. So I know that the x1's have to equal 5, so this one is 3. The question is, what's going on in my binomial coefficient? Well, I know the top term is 5, right? Because I know there's 6 terms, and I knew that I can put the 3 in there. Here's a little secret. You can put either one of these in here because of the symmetry. But the books tell you to put the 3 in there. So we're going to do that, and this is our answer. We can either do it by hand, or we know it's the row with 6 terms. Because it's to the 5th power, we know it's the row with 6 terms. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, times 8x squared, times 1, final answer, 80x squared. So you have a couple of methods. Personally, I get lazy and I just look at Pascal's triangle, but if the numbers get too big, you can't do that. Let's try another one. Here's one. Let's see. 3 plus x to the n equals 81. What is n? That's kind of interesting, right? So let's see. Well, let's see. What do you equals 81? Oh, no, I apologize. Sorry about that. Given 3 and 81, the constant is 81. What is n? Okay, well, if the constant is 80, so let's think about that. Let's think about what the constant term is. The constant term is like 81, the number. Well, there's no x there, so the x term was raised to the 0. But I still don't know what the n is, so let's look at any term. So we have n choose something, we have 3 to the something, and x to the something, right? Okay, well, I know that x has to be 0. That means 3 has to be raised to the n, and we know from practice that this is 0. So we have 3 to the n equals 81, n equals 4. So once again, when they're asking for a specific term, you know that it's in the form n choose on, so you know that. So to conclude this little mini unit, the rth term of x plus y to the n is n choose r x to the n minus r, y to the r. No. Let's start over again. No. So the x to the, let's say x to the k term of x plus y to the n is, well, let's break this down. We have n, we have x to the k, y to the n minus k, n minus k. Do you have to memorize this? No. Just know that the y coefficient goes down here. It's the n is the power of the expansion, and x is the term you're looking for. That's it. Stay tuned for part 3.